Hi guys, welcome to Piece of Code and welcome to this video. And in this video we are going to see all you need to know about EC2 on AWS for any kind of certification exam like the associate architect or the developer associate or the cloud practitioner. It will be enough if you go with this particular knowledge. Alright, so let's start with the video. So what is Amazon EC2? Basically, EC2 is one of the most popular AWS offering. So it stands for Elastic Compute Cloud, or it's an infrastructure as a service because it provides you with the servers with the actual physical memory, the storage and everything, and you just request that service and it will run on the cloud for you and you can do whatever you want with it. Okay, so it mainly consists of renting virtual machines, right? Storing data on virtual drives. We are going to see everything in detail, and also distributing load across machines, which is ELB, which is elastic load balancing. So scaling the services using an auto scaling group, ASG. So basically an auto scaling group automatically increases and decreases. It means scales out and scales in your EC2 instances as per requirements. We are also going to see that in detail later on. And knowing EC2 is fundamental to understand how the cloud works. Okay, now EC2 sizing options. So there are a lot of configurations that you can do while you are requesting an EC2 instance or creating an EC2 instance. For example, you can choose the type of operating system like Linux, Windows or Mac OS. You can choose how much compute power and cores that you need. You can choose the RAM, how much do you need. You can also choose your drives, right? EBS and EFS. If you want a file system kind of thing, you go with EFS, elastic file system. If you want a network drive, SSD network drive, then you can go for EBS, elastic block storage. Okay, also you can go for EC2 Instance Store, which is directly connected to your EC2 instance, and also you can choose the network card like ENI, and you can also choose a public IP address if you want. There are also a lot of firewall rules you can configure, and also there is something known as bootstrap script, which is EC2 User Data. I'm going to see that in a minute what it is. So EC2 User Data, right? So it is possible to bootstrap our instances using an EC2 User Data script. So what, in common terms, what it says is that, so for example, you are deploying a particular Apache web server. Okay, so what is the steps for that? Basically, you create the EC2 instance, then you log into your EC2 instance, you run commands like sudo update and everything, and then you install sudo apt-get Apache 2, and also you install the HTTPD server, right? So you do this manually. So what you can do is, while you are creating the EC2 instance, we are also going to see that in a minute. What you can do is you can easily put all of these commands in a user data script, and then you can when after the instance has been created, as it boots up for the first time, those commands will get executed and you will be having for example, Apache server running from the get-go. So it is particularly useful if you are installing updates, installing a software, downloading common files from the internet, anything you can think of. It's kind of a bash script for the first time boot up of your EC2 instance. Okay, now let's get our hands dirty and let's get to a lab about EC2 and see how EC2 actually works. Okay, so guys, let's see how we can play around with EC2 instances. So I have logged in into my AWS account, and as you can see, I am not logged in using my root user, but I have logged in using my admin user, which I had created in our IAM video. Okay, so as a common good practice, you shouldn't use your root user for a lot of stuff. You should use your admin user if you are doing a lot of stuff using your AWS account. So yeah, with that being said, let us migrate to the EC2 instance. So sorry, EC2 console. So just type in EC2 over here. So it says virtual servers in the cloud. Just click on that, and you can see I'm in the Northern Virginia region. I like that region because a lot of services are available there, and you'll face no issues over there. But you can also use the closest region available to you. It's fine, no issues in that. So over here you can see an overview of how many instances are running, what are the types of instances running, auto scaling groups, load balancers. I have nothing running as of now. So yeah, you can see zeros mostly over here. So let's launch an instance. I'll just click here and launch instance. Okay, so I'm just going to say so my first web server Okay, now what we are going to do is we are going to create EC2 instance, and we are going to put a script in the user data section, so that when the EC2 instance boots up, we will be installing a server and a simple web page. Okay, that's what we are going to do. So before doing that, so we need to select uh, uh, as a AMI. Okay, so you can use Mac OS, Ubuntu, Windows, a lot of stuff is here, but the best I think is the Amazon Linux. It is provided by Amazon itself. You can also create your own AMIs. We are going to see later on how you can do that. Okay, so you can choose the type of AMI you want to use. So we are going to use whatever available for the free tier. Okay, it will not get charged. So let's select this. Okay, now you can also select the architecture, and now here comes the instance type. We're going to discuss instance type in details in a bit, but for now the instance type actually tells you what kind of instance are you going to create, like a T2 micro. So we have a T2 micro, T1 micro, so it depends on the number of resources that you need. For example, it has 1 vCPU and 1 gigabytes of memory, and this is the cost per hour that is giving here. If you select a higher resource, for example C1 large, it has 8 vCPU and 7 gigabytes of memory, and the cost is also more. So depending on your requirements of the resources, you can choose a type of instance, but as I'm just showing a demo, so I'm going to stick with the T2 micro. Let's go with the T2 micro. Okay, and obviously this is known as a key pair. So key pair is basically, it is used for SSH into your particular EC2 instance. So I'm going to also show you how to SSH into your instance. So I'm going to create a new key pair, and here I'm going to name it as my web server key pair. Okay, and I will use .ppk file. So if you have Linux or a Mac OS, then you can use the .pem file to actually use it as a credential to SSH into your machine. But as I'm using a Windows machine, I need the .ppk file so that I can use it with Putty. So Putty is a SSH software which you can install in your machine, so you can connect it to your instance. Okay, any kind of remote instance that is available other than EC2 instances, also you can connect to any kind of remote instance. Okay, so I'm going to choose the ppk because that is the format for Putty. So I'm just going to create the key pair, and it has been downloaded over here right now. So I'm just going to leave it for now, not going to use that right now. Now coming to network settings. Okay, so not going to dig deeper into the security group and everything as of now, but just let's understand what is happening over here. So a security group is kind of a firewall for your EC2. So your security group actually allows or denies incoming traffic. Okay, so basically if you're going to deny HTTP traffic into your EC2 instance, you can use a security group to do that. So yeah, that's how you can do using security groups. You're going to dig deeper into security groups later on, so don't worry about that. So I'm going to create a new security group. It will automatically create, and I'm going to check some boxes for the rules. So allow SSH traffic from basically anywhere. So this rule is required because if I don't allow this, then I won't be able to SSH into my machine. Okay, so I need to allow this rule in the security groups. Also I need to allow HTTP traffic from the internet because I'll install a web server. So if I request the public IP address of this machine from the internet, I need to have HTTP inbound HTTP connections from anywhere, so that I can be able to access this web server. So I'll just click on that. Yeah, so HTTPS I don't require as of now, but let's also allow. Don't we'll just keep it as of now, but we are not going to do any HTTPS stuff. Now storage options over here, so you can select how much storage you need. I'm going to keep at 8 gigabytes, and this is the storage type. We're going to discuss what are storage type later on. Like depending on the storage type, you will get specific efficiency, like performance efficiency, IOPS, and everything. So we're going to discuss the types of storage later on, but for now let's keep 8 gigabytes of GP2 storage, which is general purpose 2 storage. If I click on edit now, then you can also select file systems like UFS or FSX if you need. So FSX is for Windows file server, and EFS is for Linux one, so not going to dig deeper into that. So here in the EBS volumes, we selected EBS type, and 8 GB of GP2. And delete on termination is basically, it says that this is our root volume, right, where our OS will be installed, right? In your machine you have a root volume like the C drive. So basically it says that if your instance gets deleted, then this root volume also will get deleted if you apply this permission, delete on termination. So I don't want to encrypt right now, so I'm just going to say not encrypted drive. Okay, now let's go to advanced details. Now in this advanced details, don't worry about that, just skip everything. You're going to see everything later on. The more important thing is this user data section. So I have a script ready over here. Just going to copy this thing. So if I paste it over here, then you can see this is a general bash script. So there are a couple of commands like install httpt and then yum update -y. So first command is to update the yum and then install httpd server, then start the httpd service and enable the httpd service, and then a simple web page is being created inside the var www/html directory. So I'm just giving a h1 tag and I'm just saying hello world from this particular IP address, and I'm going to redirect it to the index.html, so that will be created. So yeah, I think that's pretty much what the configurations are as of now for this particular EC2 instance. So let's click on launch instance. So it will take a little bit of time, like 2 to 3 minutes, I think so. It can be also faster than that, depending on a lot of stuff. So initiated the launch. So let me go back to instances. So it is still in pending state. It will take a couple of minutes to actually be online. So let's wait for a while. You can fast forward the video if you want. Okay, now it is in running state. So let us click on this particular thing. Let us select this particular thing and let us see some details about this EC2 instance that was just created. So in the instance summary, if you see, there are a couple of things that you need to know. So this is the instance ID, which is basically is the unique identifier for your instance. Then a public IPv4 address was associated with your instance, because if you want to access this instance over the public internet, that particular thing should have a public IPv4 address. It also has a private IPv4 address attached to it, so that basically if you want to communicate with a private IPv4 address in your own VPC or virtual private network, you can do that, but you can only do that inside your own network, not outside, not through the public internet. So this is the public IPv4 DNS. Okay, so the domain name was associated with your public IPv4 address. Then this is a private IP DNS. This is the host name. There are no roles attached to it. So as I told you, right, if you want to attach a role for this EC2 instance to access, for example, let's say the S3 service, then you can create a role with S3 service access, and then you can attach the role to this EC2 instance. We can also do that later, no issues. There's a subnet ID and a VPC ID. Don't worry about that. We are going to see that later on. Yeah, there's one key pair there. So yeah, that is all about this particular thing. Now if I just copy this public IPv4 address and I just click on a new tab and I paste it over here and I hit enter, then you can see that my web page, which is being hosted on this particular EC2 instance, is visible. Okay, so this is basically HTTP traffic, as we have allowed the HTTP traffic, inbound traffic, into our particular EC2 instance using our security group, if you remember. So that's why the instance is allowing HTTP traffic into it, and we are able to access the website. So this is actually the private IP of the particular instance. It is not the public IP. So basically this is your public IP. So I have, in the script, if you remember, I just wrote some code so that the public IP of that, the private IP of that instance will be displayed. I'm just displaying it on the HTML web page. That's it. So yeah, that was about it. This is how you create an EC2 instance. Now let's talk about a little bit something else. Let's see some actions which you can perform on then EC2 instance. So instance state, so instance states, if you go, now there are a lot of options over here. There is stop instance, there is reboot instance, there is terminate instance. So let's stop the instance. Now when you stop an instance, basically it is good if you stop the instance when you don't need it, because obviously you are going to be billed if you are keeping your instance always running, right? Obviously you are going to pay for the storage, but still the bill will be a lot less, right? And basically when it is in stopped state, you will not get billed for this instance. Okay, now this is in stop state, and let's restart this instance, right? So let us go to instance state and let us start this instance. Okay, now let us wait for a while. Okay, now it is in running state. Now let's see some fun stuff about this instance, right? Now if you see, if I go back to my public IPv4 address which I had kept over here, and if I try to reload it, then you can see that it is not able to reach that instance. And the reason is that when you stop an instance and when you restart your instance, the public IPv4 address is changed. So AWS gives you an ephemeral public IPv4 address. It means that the public IPv4 address can change. Okay, but if you want a static IPv4 address and you don't want it to change, then there is something known as elastic IP, which we are going to discuss later on. But remember that this public IPv4 may change. Alright, so you can use your public IPv4 DNS if you want, or otherwise we are going to see other good techniques like using a load balancer and everything later on. But for now, just remember that your public IPv4 address may change and it may cause issues if you are using this in your application code. Keep that in your mind. Okay, so you can also terminate the instance like this, but I don't want to terminate that instance right now because I want to do some other stuff also. So yeah, this is how you create an EC2 instance on AWS. Okay guys, so let's see some other topics right now, and let's see what are the instance types that is available, and let us see what we can learn about the instance types. So you can use different types of EC2 instances that are optimized for various use cases, right? Like there are general purpose, compute optimized, memory optimized, accelerated computing, storage optimized, instance features, and measuring instance performance. Now a particular AWS has a following naming convention which says M5.2x large. It means that, so M determines the instance class. So this is a memory optimized machine. So memory optimized machine, we are going to see what class it belongs to later on. So it's an instance class. So 5 is the generation, and AWS improves them over time. Okay, 2x large is size within that instance class. So it's kind of says that okay, this is the 2x large, like आपका जो Excel आता है and double Excel आता है आपके जो कपड़ों में, same thing is happening over here. Okay, a very vague comparison, but I think it works. Now general purpose types, right? Let's see what are the general purpose types. So it is great for, if you select this kind of instance type, right, it is great for a diversity of workloads such as web servers or code repositories, and it has a balance between compute, memory, and networking. So everything is balanced in this instance type. So in this particular course, you will be using the T2 Micro, which is a general purpose EC2 instance. Okay, because it comes under the free tier. Talking about compute optimized, so as the name suggests, right, it is good for compute intensive tasks that require high performance. Okay, so for example, it require, if you need high performance processors, you will use the compute optimized. For example, like batch processing workloads, media transcoding, high performance web servers, high performance computing, which generally requires the good processors. Okay, you can also choose a lot of good processors if you want to use for the compute optimized. Now memory optimized, basically if you need a lot of RAM, okay, like in memory, you want to run an in memory database, or you want to do some stuff which is uses a lot of volatile memory, you can use the memory optimized class, and they have some pre-configured instances which you can use. For example, you want high performance relational or non-relational database, right? You want a cache, okay, highly performing cache you can use this. In-memory databases optimized for BI, business intelligence reporting. If you want those kind of things, you can use memory optimized. Now let's go to storage optimized, and as the name suggests, if you want a lot of store, right, like your hard disk drive, you want a lot of storage in your hard disk drive, like the drives we saw like in EBS volumes, you need a lot of EBS volume and storage, then you can use the storage optimized type. So great for OLTP systems, right, online transaction processing, where you store a lot of data and you just kind of query the data for analytics purposes or something like that. Relational and NoSQL databases you can use. Cache for in-memory databases, for example Redis you can use. Data warehousing applications, distributed file systems. So it is for storage intensive tasks. So if you see an example, so basically instance types, T2 micro, we have over here, we have T2 X large. So basically this is an example of what instance types are. So basically this is how you can use it. You don't have to remember everything, the instance types, like the names and everything. Just remember compute optimized T2 micro or something like that, right? Just remember that there are various types for various use cases. For example, if in the exam the question comes in like for high performance computing, obviously you will go for which compute optimized types. Okay. Now talking about another thing, I just need to say that it's not that you have to bind yourself to the instance types itself, right? As we saw in our demo, that we can also configure our own resources using the console, right? You don't have to always select an instance type and based on that you have to do it. You can also configure number of vCPUs, memory, storage, network performance on your own also. You don't have to select a particular instance type every time. You can do that. So it is manually configurable. Now talking about security groups. Okay, so security groups are the fundamental of AWS network, right? We are going to learn about security groups in very big detail in VPCs, okay, but for now just understand that they control how traffic is allowed into or out of our EC2 instances. Okay, and security groups only contain rules. So security groups rules can reference any IP or by any other security group. Okay, so we're going to see some examples right now. Basically it's kind of a firewall for your EC2 instance. It will allow or deny traffic, whatever traffic you want and everything like that. So a deeper dive of security groups. So security groups are acting as a firewall, as I told you, on your EC2 instance. They regulate access to ports, authorize IP ranges, like what IP ranges you want the traffic to be sent to or receive. Okay, control of your inbound network from others to the instance, like from anywhere to your instance, and control of the outbound network, the traffic which goes from your EC2 instance. So if you can see this particular rule table, it basically shows that of a security group. For example, you are there is a HTTP protocol, HTTP type data, data, and then we have protocol as TCP, and then the port range is given is this. So from anywhere you are saying that you are allowing the data from anywhere, right? That's why the 0.0.0.0/0 is given here. You are allowing SSH access, which is also TCP protocol, and the port range is 22, and the source you have given is from a particular IP range. Okay, if you see over here, I have mentioned a CIDR block. You're going to learn what CIDR blocks is later on. Okay, so you can control the flow of traffic into your EC2 instance in simple words. Okay, now understanding visually. If you see this particular diagram, it will give you a lot of things what I am saying. So this is a EC2 instance, okay, and inbound rules, filter IP, port width rules. So other computer not authorized, port 22. So if this one is not authorized, it will not allow SSH into this particular EC2 instance. So it is blocking that access over here. But you have authorized port number 22 on your computer's IP range, right? So it is allowing the SSH access. The security group is allowing SSH access to your EC2 instance. Okay. Now if you see over here, you have defined some outbound rules. So you are going to say, okay, whatever traffic is leaving my EC2 instance, it can go to anywhere. So you also have an outbound rule. Okay, so you have inbound rules and outbound rules. So that is how a security group works with a EC2 instance. Now some important points to remember regarding security groups. So remember that can be attached to multiple instances. It means that one security group can be attached to multiple instances. Okay, it's not that one EC2 instance should always have one security group. And EC2, these security groups are locked down to a region or a VPC combination. Okay, so it's a regional service. You cannot use a security group which is made in another region. For example, it is created in US West 1 region and you are going to use it in US East 1 region. It is not possible. It does live outside of the EC2. So if traffic is blocked, the EC2 instance won't see it, obviously, because the security group allows or denies the traffic. So the EC2 instance will not be able to know if any traffic was blocked or allowed. So it is good to maintain one separate security group for SSH access, so that if you create one only security group for all of your rules, then maybe it can jumble up your mind, right? If there is a specific security group for SSH, you can control that access, because SSH is a very, very destructive kind of an access. Because if you, for example, allow SSH access from anywhere and some kind of hacker tries in and SSH into your machine, basically he or she has all the access to your machine. So that is very, very important that you remember. If your application gives a connection refused error, then it's an application error or it's not launched. Okay. So basically, the thing is, if for example, if you see over here, I used my public IPv4 address, and basically I was able to, sorry, let me just copy this public IPv4 address. So you can see that I'm able to access my EC2 instance, right? But for example, for some reason it reloads and it keeps on reloading, but you are not able to see this particular page, then it means that there is some issue with your security group. There is a particular rule in your security group which is not allowing that HTTP port. Okay, if you have some HTTP access and you are not allowing in your security group, then basically the data will not go through it. Okay, so but if your application gives a connection refused error, then it's an application error. It means that the HTTP traffic is going to your machine, but there is some error in your code that you have hosted on your particular EC2 instance. Okay, so make sure you remember all these points. All inbound traffic is blocked by default and all outbound traffic is authorized by default. It means that anything leaving your EC2 instance, right? Any kind of data leaving your EC2 instance is allowed by default. It can go anywhere, but inbound, like any data that is accessing that your particular EC2 instance, is blocked by default. So allowing or denying other security groups. Okay, it can seem a little bit of complicated right now, but when we are going to dig deeper into all these things like security groups in the VPC chapter, it's going to be very easy. For example, if you see in this particular diagram, we have an EC2 instance and we have some inbound rules in our security group 1. So it is authorizing security group 1. So this particular security group, which is attached to another EC2 instance. Okay, so basically it says that, okay, so there is a port 123 on EC2 instance. So any data coming to the port 123 from security group 1, means from the EC2 instance, this EC2 instance is allowed in this particular EC2 instance. Sorry, in this particular security group. So it authorizes security group 1 to send inbound data into this EC2 instance, and also it is also authorizing this security group 2, okay, which is attached to another EC2 instance, to send the data here to this particular EC2 instance. So this security group allows security group 1 and 2 to send some inbound data into this particular EC2 instance, but it has blocked a particular security group 3 from accessing this particular EC2 instance. So you can restrict data flowing, inbound data coming in using IPv4 ranges, IPv6 ranges, security groups, other security groups, and a lot of other stuff. Okay, so you have full control of how you are restricting and allowing your data into your EC2 instance using your security group. We're going to see all this in detail, so don't worry about it. Okay, so some common ports to remember. Okay, so basically we have some 22, which is secure shell, okay, SSH, 21 is FTP, 22 is SFTP, which is secure file transfer protocol, 80 is HTTP, 443 is HTTPS, 3389 is RDP. Okay, so this is how you should remember all these ports, because these are very common ports and people also ask questions on it, and some questions also come to it. Okay, alright, so let's move on to the next topic. Okay guys, so let us see something about security groups. Okay, So here you can see my instance is running and everything, and I have a security group attached to it. So let us go to this particular nav bar, and let us go to security groups. And over here, if you see, there are a couple of security groups over here, and this was created by me. This was some default security group, don't worry about that. So one thing we need to see is this launch wizard one, which was created with our EC2 instance, right? So basically let's click on that and let's see what is here. Now to have a good look, let's go to the inbound rules, right? And let's click on edit inbound rules to have a good look. If you see this inbound rules for the security group, then there are certain traffic which is being allowed. For one is the SSH traffic. So you can select the type of traffic that you want, for example SSH, and the protocol is TCP, port range is 22 obviously. Then the source, you can select a couple of sources, so IPv4 anywhere, IPv6 my IP, and also for example if you want some other rules to give. For example, I want to add a new rule for a custom TCP, for example ICMP IPv4, and the source you can mention like custom. If I say custom over here and I put over here, then you can see a lot of things you can actually restrict your traffic or allow the traffic. For example, you can use CIDR blocks. You can use other security groups. For example, there is another EC2 instance which wants to communicate with your EC2 instance using the ICMP protocol. Then you can, so for example, allow that particular security group. Okay, so that EC2 instance now will be able to send ICMP traffic to this particular EC2 instance. So there are a lot of things, but don't worry about all these things. We are going to learn these techniques in the VPC chapter. So let's delete this thing, I don't want it. Now we have allowed HTTPS and HTTP traffic, right? So let us delete this HTTPS traffic. I don't want it right now, and we are not accessing HTTPS. Now as HTTP is allowed from anywhere, right, from any source, that's why if we refresh this, so basically this is HTTP, right? So if I go over here and say HTTP, so basically :/, so this is HTTP, and then we are going to provide our public IPv4 address. So if I load it, then I'm able to access this web page. For what happens if I delete the HTTP rule, right? If I delete this thing over here, okay, so it now my security group only allows SSH access from anywhere. Okay, so if I go back and I try to reload this page, right, so it's still reloading. I think it is cached or something. So let me just copy this particular IP. It takes a little bit of time to take effect, but let's open a new incognito window and let's paste this particular thing and let's hit enter. Okay, still allowing. Weird. Okay, so okay, so I didn't save the rule, my bad. Okay, now my security group rules are saved. Okay, so let us go back and let us try it again. Now if you see, now I'm not able to access my HTTP my server, right, because the HTTP rule is now not allowing by the security group. So no HTTP traffic can reach my instance because I have denied that traffic. I mean, I have removed that inbound rule. So let's add it back. So let's go to edit inbound rules and let's add a rule for HTTP. So you can select HTTP from here. Where is it? And let us say port range, source is anywhere, IPv4, and let's save the rules. Okay, now as I just save the rules, if I go back to my instances, for example EC2 dashboard, I think I lost it somewhere, running instances. Okay, you can also use your public DNS, so we can open the address and okay, it is using HTTPS. So let's do one thing, let's copy this public DNS and let's paste it. I don't know, I think it's still taking HTTPS. Okay, let's change it to, so by default what happens is that all your traffic goes as HTTPS, because now it is a good mandate to use HTTPS. So you have to specifically specify that okay, you want to send HTTP traffic. So yeah, make sure you do that, but it's a good practice to always send HTTPS encrypted traffic, because obviously you don't want unencrypted traffic to travel through the public internet. So you can see now we are able to access our server, okay, because we changed our security group and now it allows HTTP access. Okay, so this is how you manipulate your security groups, and you can allow inbound and outbound rules, and you can deny some rules and everything based on your requirements. Now let us see how you can connect to our EC2 instance using SSH. Now there are a lot of ways to do that, and let us see this SSH connections table. Okay, so there are three ways of connecting to your EC2 instance. One is using SSH, one is using Putty, and one is EC2 Instance Connect. So basically, don't worry about EC2 Instance Connect as of now. Let's talk about this SSH and Putty. So if you are using a Mac, you can directly do SSH using your command line interface, no issues in that. Linux also the same thing. But if you are using a Windows machine, there are certain conditions. If you are using a Windows machine which is less than 10, okay, then you can only do SSH using Putty. If you are using Windows which is 10 or greater than that, or 11, you can directly do SSH using your PowerShell, and you can also do SSH using Putty. But in this particular demo, we are going to see how to connect to your EC2 instance using Putty, and later on we are going to see EC2 Instance Connect. Now let us do this thing. So let me just open up Putty. It is very easy to install Putty. Basically, you just type install Putty in your particular web browser, and then you can just download the MSI installer and install it on your Windows machine. So now what I need to do is, I need to use my key pair, and along with my key pair, I need this public IPv4 address, right? Because the connection will go over the public internet. So host name or IP address. Now in this host name, I need to give two things. One is the user that was created with my EC2 instance. So default user known as EC2-user is being created with every instance that you create in the EC2 console, using the EC2 console. You can create your own users using Linux commands after you SSH into your machine. Okay, you can use it like a normal Linux machine later on, but by default an EC2 user is being created, so you can use that to log in. So EC2-user, then @ and then provide the public IPv4 address. So connection type SSH. Okay, don't want to create a save session because this, I think this is the last time I'm going to use Putty, so that I just want to show you how to use Putty, but mostly I will use EC2 Instance Connect. So after that, if you click on open connection, it will generally not connect because you need that .ppk file, right, that key pair, otherwise you will not be able to log in. So you just go to SSH and auth and auth, and then you need to, what you need to do is credentials, and then you need to go to private key file for authentication. So basically, let's browse that thing. I had downloaded that, if you remember. If I go to downloads, and I'll just select this key pair, okay, and then I'm just going to open the connection. Okay, I'll just accept. Now you can see that we have we have actually logged in into our EC2 instance. This is a SSH connection. So yeah, you can run commands or anything. You can run commands. For example, you can create a file, for example test you can create site, for example touch text test.txt. so it's kind of acting like a normal Linux instance, right? If I do an ls over here, you can see that is created. Okay, so that is how you can SSH into your machine, EC2 instance, right? Let's talk about some SSH troubleshooting steps and some important things about SSH troubleshooting. Now basically, students have the most problem with SSH, and if things don't work, then basically rewatch this particular lecture and see what I have followed to do. You may have missed something or something like that. Read the troubleshooting guide that is present in the AWS website, and also try EC2 Instance Connect, which is way much easier than this particular SSH, right? If one method works, then basically you are good to go. If your EC2 Instance Connect works, then it's fine. If Putty works, then it's also fine. If you are able to SSH, then it's also fine. So I think you know the steps to how to SSH into your EC2 instance Windows. Then I don't think I need to explain it any further. Okay, now let's talk about EC2 Instance Connect. Now connect to your EC2 instances within your browser. So basically, no need to install Putty, no need to do SSH, no need to create key pair, nothing is needed. Only you just have to click on one button and it will establish a SSH session on the browser itself. So it is kind of a temporary key which is uploaded into EC2 by magic. We don't know what is happening. Works only out of box with Amazon Linux too. So when you are selecting the AMI, make sure if you want to use EC2 Instance Connect, use the Amazon Linux 2 AMI, and you need to make sure that port 22 is opened on your security groups, otherwise it will not work. So let us go and see how EC2 Instance Connect works, right? Let me go over here and let me just click on this instance ID. Okay, now just click on connect over here. Now you can see there are a lot of options over here, but what we are interested in is the EC2 Instance Connect. So basically you just need to click on connect over here, right? That's it, that's all you need to do. So see, basically it just created the connection and you actually didn't do anything. So this is the power of AWS. Now if you see, we have established a secure connection. If you want to, let's say, verify, we had created a file using our SSH, while we SSH into using the Putty. So if I do an ls over here, then you can see the test.txt is still present there. Okay, so yeah, this is how you do SSH into your EC2 instance, and this is how you use EC2 Instance Connect, which is way much easier than using your SSH, normal SSH techniques. Okay, now let us talk about EC2 instance purchasing options. Okay, because there are a lot of types of instance we saw. Now there are certain purchasing options that you should keep in mind while you are actually going for the EC2 instances, while you are actually creating an EC2 instance. So there are certain types of instances, for example, on-demand instances, reserved instances for 1 or 3 years, convertible reserved instances, savings plan, spot instances, dedicated hosts, dedicated instances, capacity reservations. Based on how you are going to use your EC2 instance and your workloads, you are going to select the purchasing options. For example, your workload is a long-term workload, so you want to save a lot on money, so you can go for reserved instances. Let us see one by one in action. So EC2 on demand, basically pay for what you use. So basically you just create the EC2 instance and your billing will be, as you keep on using the EC2 instance, it will bill you according to your usage. So it will be, so for Linux or Windows kind of instances, it will billing per second as you use it, it will be billed accordingly. So after the first minute, it will start billing per second. For all other operating system, for example Mac OS, it will be billing per hour. Has the highest cost, but you are not going to give any kind of upfront payment. There is no long-term commitment. As you create a EC2 instance, you use a EC2 instance, you are going to pay for that particular EC2 instance. That's it. It is recommended for short-term and uninterrupted workloads, where you can't predict how the application will behave. So you have started as a for example a startup, and you have your application, but you don't know if there will be a lot of traffic for your application, or how many if your application is going to be persisted, you don't know, right? If your application will go over the time, it can run for a year or 6 months, you don't know anything. So you can use EC2 on demand for your servers. Good option for that. Talking about reserved instances, now the best thing about this is that you can get up to 72% discount compared to on-demand instances. So you reserve a specific instance attributes like instance type, region, tenancy and OS. Reservation period is 1 year or 3 years, and as you reserve for more years, you will get the most discount. For 1 year it is some discount, for 3 years it is a lot more discount. Payment options, that is you can give no upfront, you will get some discount. If you give some partial upfront money, it means you pay for it from the beginning, then you will get some more discount, and if you pay all the money from the start, all upfront, then you will get the maximum discount. Now reserved instance scope is regional or zonal. Okay, so basically it will be bound to a region or a zone or availability zone. Recommended for steady state usage applications like a database. You can buy and sell in reserved instance marketplace. Okay, so you can, if you have purchased some reserved instances, you can, for example, create your own AMI and you can just sell it on the AWS marketplace. Convertible reserved EC2 instance, it means that you can change the EC2 instance type, instance family, OS, scope and tenancy. The thing is, with normal EC2 reserved instances, you are fixed with that particular instance type, region, tenancy and OS. You have to use that for your commitment period. But if you work with convertible reserved instance, then you can change the instance type or instance family. For example, you had gone for a x2 large, okay, but you see that, okay, as I predicted, the workload is not that much, so I want to change it back to a lower instance type. So you can do that for a convertible reserved instance, and you will get a little bit less discount. You will get up to 66% discount in this thing. Talking about EC2 savings plans, it is get a discounts based on the long term usage. Don't confuse it between the reserved instances, okay. So here what you do is you commit to a certain type of usage. It means that, okay, I am going to use like for example 3 hours each day with $10 an hour, and I'm going to use it for 1 to 3 years. You are making a commitment, but not on the particular instance, but on how much you are going to use that instance. And usage beyond that particular point, if you use more than that, then it will be billed according to the on-demand price, and you can get a discount up to 72%, same as the reserved instances. It is flexible across instance size, example mx large, mx 2x large, or something like that. And also you are flexible in choosing the OS and the tenancy. We are going to see what tenancy is in a minute. Okay. Now talking about EC2 spot instances. Okay, you can get a discount up to 90% compared to on demand, and this is one of the most, I think it is the most discounted type of purchasing option. So basically instances you can lose at any point of time if your max price is less than the current spot price. So basically if you are going for a spot instance, remember that the spot instance can be taken away from you at any point of time if that particular instance is required somewhere else. And ऐसा नहीं है कि बस आके ऐसा मुंह उठा के ले जाएंगे तुमसे. There is a certain rule regarding to it, and we are going to discuss how you get the spot instances and how your spot instances are taken away from you. But as for spot instances, it is for workloads that can be interrupted. You cannot use spot instances, for example a database, because a database needs to keep on running. If that instance is taken away from you at some point, your database will be down and your website will be down, right? So you don't want that. So it is useful for workloads that are resilient to failure, like batch jobs, data analysis tasks, image processing, any distributed workloads with a flexible start and end time. Not suitable for critical jobs or databases. Remember that. Now let's talk about EC2 dedicated hosts. Now this is a physical server with EC2 instance capacity fully dedicated to your use. Now remember, when you are actually demanding or creating an EC2 instance, right, you are not getting a complete physical machine to yourself. There is something known as virtualization happening on the background. Now virtualization, it's a very vast topic, but to explain it in a smaller terms, virtualization is a technique which you use so that you can create multiple instances on your single hardware. For example, you have a particular laptop like mine, and you want to host 4 or 5 operating systems on that particular hardware. It will kind of behave like different machines. So basically that is how you want to do it. You want to host multiple operating system on your physical hardware. You will use something known as virtualization, and you can do it using some virtualization tools like VMware and Oracle VirtualBox or something like that. You can try that out for your local virtualization thing, but that is what is happening. But for example, if you want a physical server which will be dedicated to you, you can go for EC2 in dedicated hosts. Okay, allows your address compliance requirements and use your existing server bound software licenses. Okay, so there is also some purchasing options in this thing. For example, you can go for on demand, which is pay per second for active dedicated hosts, and there is reserved, which is 1 or 3 years. And same thing is that basically you can go for no upfront, partial upfront, or all upfront. So this purchasing option comes under dedicated host. So if you select dedicated hosts, you can either select that dedicated host server as an on demand, like you pay for example 2 hours or 3 hours which you are using, or you can reserve that particular physical server for 1 year or 3 years. It is the most expensive option because a dedicated server is allocated to you instead of virtualization, and it is useful for software that have complicated licensing model. For example, there is some compliance requirement where you cannot host your application in a shared hardware model like in normal EC2 instance. You want to have a dedicated instance or a server located to you. Okay, it's for companies that have strong regulatory or compliance needs. Okay, makes sense. Now there is also something known as dedicated instances. Now don't confuse between dedicated instances and dedicated hosts. So instances run on hardware that's dedicated to you. Okay, it's not a server, it's just some hardware that is being dedicated to you. That is the difference between dedicated instances and dedicated hosts. Okay, now may share hardware with other instances in the same account. So that hardware is given to you, but it can share that hardware with some other instances in your same account. Okay, but that hardware is dedicated to you. Don't worry about that. So you can move hardware after stop and start. So if you see this table over here, enables the use of dedicated physical servers. So you are going to get the servers for both of them. Per instance billing is in dedicated instances because multiple instances can run on your dedicated server, right? But in dedicated hosts, you cannot run multiple instances on your dedicated host. Imagine like this thing. So basically when you're getting a normal EC2 instance, so there is some server and a lot of other accounts also have EC2 instances on the same server, right? Same physical server. That is the virtualization technique. But when you go for dedicated hosts, that server and there will be only one instance on that particular server and it will be allocated to you. You cannot create multiple EC2 instances on the same server. But if you go for EC2 dedicated instances, you will get that hardware and server, but you can create multiple EC2 instances in the same account. Another person in a different account cannot create an EC2 instance on the hardware allocated to you. You are going to create that, or someone else in your organization is going to create that. Other things are similar to dedicated hosts, right? Most of the things. Now EC2 capacity reservations is another technique which says that, okay, reserve on demand instances capacity in a specific AZ for any duration. Okay, so this is kind of a tricky thing. Okay, and how it happens is that you reserve some on demand instances for a specific AZ for a duration. Okay, you are not reserving it for a particular 1 year or 3 year. Okay, like or you are not specifying a particular hardware, or you are not going for a savings plan. You are just taking, okay, I want these on demand EC2 instances in this particular AZ, for example US East 1. You will always have access to EC2 capacity when you need it. Okay, so that's what I mean. No time commitment, create and cancel anytime, no billing discounts is available because you are obviously using on demand instances only, but you are just reserving it in a particular availability zone. So if you combine it with regional reserved instances and savings plan, you can benefit with some discounts. So you are charged at on demand rate whether you run your instances or not, and this is where it becomes a little bit tricky. Now basically when you stop an instance, you are still going to pay for it because you have reserved that particular capacity. Okay, suitable for short term uninterrupted workloads that needs to be in a specific AZ. Okay, so these are the requirements. Now very easy way to understand what is how to choose purchasing option is that consider this as a hotel. Okay, this is a resort or a hotel, whatever you want to say. So on demand is going to be like this: coming and staying in the resort whenever we like, we pay the full price. Okay, reserved is like planning ahead, okay, and we are going to plan to stay for a long time. We may get a good discount. For example, there is some discount in a resort. If you stay for 3 months, you are going to get 50% discount, something like that. Then comes to savings plan. Pay a certain amount per hour for a certain period and stay in any room type, like king, suite, sea view or something like that. So you are going to say, okay, I am going to pay this much of amount for per hour for a certain period. Okay, I am not going to book any kind of room, and I can stay in any kind of room type. That is fine. I can choose later on also. It's no issues in that. Then come to spot instances. The hotel allows people to bid for empty rooms, and the highest bidder keeps the particular rooms, and you can get kicked out at any time. Okay, so basically, for example, there is a particular rooms which is available, and basically the hotel, what it does is it basically puts a bid. Okay, so $500 or $500 is the particular starting bid price. So as particular people start on increasing the bidding price, then that particular price also increases. So for example, at a particular point of time, the person who was staying in the room by paying 1000 rupees, certainly the particular bidding price has increased to 1200 rupees. Then that person will get kicked out, and whoever other person who is going to pay more than 1200 rupees will get that particular room. Simple as that. So it is kind of spot instances also work like that, and we are going to see in detail how spot instances work. Same kind of technique. you actually give a bid. Whoever pays more than that bid or that particular bid, then that person gets the room. Then dedicated hosts, we book an entire building of the resort for ourselves. Okay, we go for, okay, whatever rooms is in there, I'll just book the entire building. Then capacity reservations, you book a room for a period with a full price, even you don't stay, it's fine. I'm just going to book a particular room for a particular period and I'm going to pay the full price. Okay, I don't care if I want to stay in it or not, that's up to you. Okay, so that's are all the purchasing options which are available in EC2. Okay guys, so let's talk about roles. Okay, so if you remember in our IAM section, we learned that roles are something that you can give to a service in AWS, and that service will perform the requested actions on your behalf. Okay, it is much more safer and it is much more better to use roles with services instead of providing your access key and secret access key or your other credentials. Now let me go to IAM and let me create a role for our EC2 instance that I had created. Okay, we have one EC2 instance and I had created that. So yeah, so what I'm going to do is I'm going to create a role and I'm going to say that, okay, this role has some particular permissions for IAM read-only access. Okay, so that anyone who is attached to this particular role or wherever you attach this role will have access to read IAM users. Okay, so I'm just going to search for that IAM read-only access, right? So I'm just going to select this policy over here and I'm just going to go to next and I'm going to name this as EC2 IAM read only role, something like that. And yeah, that's it. Now let's create the role. Okay, so the role has been created. Okay, so if I go to roles and if you see, we have a couple of roles over here, and the only one that we are going to be using is this read only role. Okay, IAM read only role. Now let us go over to our EC2 instance. So my EC2 instance is here, we had created it later on. Now let us go to actions. Okay, and let us go to security and modify IAM role. So currently this particular EC2 instance is not associated with any IAM role. So what I'm going to do is, before I attach that role, I'm going to go back to my EC2 instances. Okay, we are going to attach it in a minute, just a minute. I'm going to go to this instance of mine and let us connect to this instance using EC2 Instance Connect. Okay, let's connect. So whenever you are creating an EC2 instance, right, it comes with installed AWS CLI. So you don't have to reinstall AWS CLI on EC2 instances. It comes with that particular thing installed already. So if I try to issue a command like AWS IAM list users, okay, then it says that unable to locate credentials. So what is the technique to do this? Basically, you need to run AWS configure. Okay, and then you need to provide your access key, secret access key, region name and something, and then if that particular user has that particular access to read users from IAM, then you can read it from here. But the thing about it is not a very good practice to do this, because see, if I just provide my secret access key and access key over here, so basically I have logged in as a user over here. So if any other person has an access to this particular EC2 instance in my organization, that person can connect to this EC2 instance and can run those commands, and that is really bad. We don't want that to happen, right? Because we have to follow the principle of least privilege. So the better way to do this is to use the concept of roles. So we will as I have attached the policy of having IAM read permissions into that particular role, we will just attach that role to this EC2 instance, and then this EC2 instance will be able to issue the commands for IAM read users on our behalf without using credentials. Let us see. So let me go to EC2 instances right now, instances. select this instance. Now if I go to actions right now, security, and modify IAM role, and I'm just going to choose the IAM role which I had created. So read only IAM EC2 IAM read only role, and I'm just going to update the IAM role. Now that particular IAM role is attached to my EC2 instance. Okay, so if I go back to my EC2 instance and try to issue the command AWS IAM read, sorry, what was that, list users, then you can see I am able to list the user in our particular EC2 instance without providing any credentials, because we directly attached a role to this particular EC2 instance. Okay, so that's where the roles actually come in handy. Okay, I hope you guys have understood what I'm trying to say. Okay, now you can do a lot of stuff with this. So if I go to my EC2 read only role, and for some reason you don't want that EC2 instance to communicate with IAM anymore, so you can just select the policy attached to it and just remove that particular thing. So if I remove the policy from that role, then basically if I go back to my EC2 instance and if I run that command, so an error occurred, access denied. So you can see how fast it is. And if I want back that particular policy, then I will just add that particular policy to the role again. So IAM, that is IAM read only access, I'll just add back that policy, attach policies, and policy is successfully attached. If I go back, let me just clear the screen and let me just run the command again. Okay, you can see it is again. So it is so easy to do all this stuff using roles instead of using credentials. So try to understand the scenarios where you need the access key, secret access key and everything, and the scenarios where you need the role. Okay, so then you will be able to easily differentiate when to use what. Okay, so that's about instance roles and everything. So let us go back to our slides and let us talk about EC2 spot instance requests. Now we talked about spot instances, but how does the request actually work? So you can get a discount of up to 90% compared to on demand, that we already know. Define a max spot price and get the instance with current spot price less than max. So basically you are giving a bid, and if the current spot price or current the price is less than your bid, then obviously you win and you will get the instance. Okay, another thing to keep in mind is that the hourly spot price varies based on offer and capacity. For example, you got an instance right now because your spot price is your max price is actually greater than the spot price, so you got the instance, but after let's say 2 or 3 hours the spot price goes over your max defined price sorry, your max defined price. So what will happen, that particular instance will be taken away from you. So basically you will get a 2 minutes grace period to run any kind of scripts before it goes out of your hands. Okay, other strategy is to use a spot block. Now block means spot instances during a specified time frame, 1 to 6 hours without interruption. So you can just request a spot instance for like 1 to 6 hours using a spot block, and it will not get interrupted. Okay, but in rare situations, okay, the instance may be reclaimed. Okay, so there is no guarantee that even if you use a spot block, you will get that instance for those couple of hours. Only when your current spot price is less than your max price, less than your current defined max price, then up till that point you will have your instances. So basically it's used for batch jobs, we already saw that, not great for critical workloads like databases. Now if you see the pricing over here, so user defined max price, okay, so you can see that based on different availability zones also the spot price fluctuates. Okay, so at some point of time US East 1 was less than that particular max price, so you will get the instance, then it goes over your max price, so you will lose the instance at this point, then then it is lower, then it is higher, and it goes like this. So the only rule you need to follow is that if your max price is greater than the spot price, you will get the instances. That's how it works. So terminating spot instances. So let us see what does this mean. Now there are two types of spot requests. One is a one-time spot request and another one is a persistent spot request. Now in persistent spot request, what happens, if your EC2 instance get terminated, it will request back the particular spot instances. Okay, so if you see, start a persistent request. So this spot request consists of a maximum price, desired number of instances, launch specification, whatever details you need, then it will launch the instances. Okay, so basically what will happen, if it is a one time request, then it will get interrupted, that is fine. But if it is a persistent request, it will re-request those details because there was some interruption or the spot instances were taken away from you. It will re-request, and this cycle will carry on until you cancel your spot request, persistent spot request. It will keep on requesting for those instances. Okay, but if you have a one time spot request, then it will only request it one time, and if it is interrupted, then it is gone. The spot instances will not be requested anymore. Okay, so basically keep the one thing in mind is that you can only cancel spot instance requests that are open, active or disabled. Okay, so this is the life cycle of a spot request. So you create the request, it is an open state. For example, your max price is less than the spot price, so it failed. Okay, but that is one condition. But then your everything is fine, so it is an active state. Okay, then maybe some reason it got cancelled, that can also happen. Then if there is a particular persistent request and if it is disabled, then it will go back and open the request again. But if you close the request, then it is done because it is a one time request. Okay, so this is the cycle. And remember one thing, that if you have a persistent spot request, first cancel a spot request and then terminate the associated instances. Why? Because as you have a persistent spot request, if you terminate your spot instances, then that request will request again for those instances. As you keep on terminating your spot instances, it will re-request them, and because it is a persistent spot request, right? So what you have to do is first cancel the persistent spot request, so that even if your instances get terminated, the spot requests will not request them again. Okay, so remember two types of spot requests, one time and persistent. Remember the cycle of this spot request. Don't have to remember all of this for the exam, just remember that how to request for spot instances. That should be how it is. Okay, now let's talk about spot fleets. Spot fleets is a set of spot instances plus on-demand instances. Spot fleet will try to meet the target capacity with price constraints. For example, there is some job or a particular application you are running. It has a couple of batch jobs and it has some critical jobs. So you can use a mixture of spot instances and on-demand instances by using spot fleet. So basically, the advantage of this is that instead of using on-demand instances for all your workloads, you mix it up with some spot instances, so that your prices will be really less. Okay, now strategies to allocate spot instances. One is the lowest price strategy. So from the pool with the lowest price, so basically it will pick up the instances which are the lowest price. Mostly spot instances will be preferred in this thing. Diversified, distributed across all pools. Sorry, great for availability and long workloads. Then is capacity optimized, pool with the optimal capacity for the number of instances. So there are three techniques how you can create your spot fleets. So spot fleets allows to automatically request spot instances with the lowest price. So spot fleets, just to remember in one line, it is a mixture of spot instances plus on-demand instances. Okay. Okay. So before we done with this section, let us see the types of instances that we can do. So if we go over here and if we go to spot requests, right, I'm not going to request actually because it will actually cost a lot of money, but I'm just going to show you how to actually request for spot instances. So request spot instances. Here you can use a launch template. Don't worry about a launch template, we are going to discuss that later, but let's see manually configure launch parameters. You select the AMI, select the key pair name, additional launch parameters. If you see you have some EBS volumes you can configure. Okay, then you can select the tenancy also. Okay, you can also get a dedicated instance as a spot instance, you can also do that. You need to attach some security groups, you will do that. Auto assign IPv4 public access, whatever. If there is some user data that you need to run, you can put it here. Some additional details. So target capacity, what is the number of instances that you want to keep. Okay, so if it is 10, then it will maintain 10 instances, right? Now going to network part, you select the VPC, you select the availability zones and everything. Then we have instance type requirements. You can configure the vCPUs and everything, and basically you can also select memory gigabytes or whatever you want to know. Okay, and you can also select a instance type directly. Okay, instead of giving vCPUs memory resources on your own, you can directly select a particular instance type like C1 medium, CX large, something like. You can also select a mixture of a lot of things. Okay, so that will create a spot fleet for you. Now allocation strategy, you want a price capacity optimized recommended, like you want the lowest price, or you want capacity optimized, like request spot instances from your most available pools. This strategy has the lowest risk of interruption. So basically if you are price constrained, then go for this, otherwise you can go for this. Okay, and also if you see, there are certain things, there are a lot of instance types. Basically you can select for any kind of instance types. Okay, so yeah, so if you see, so the estimated hourly price is something like this. Okay, so it kind of gives me 80% savings compared to on demand. So basically that's what it is. So you can do that. So this was about spot request, how you can create a spot request. Let me go back to EC2 and let us talk about so if you don't want a spot request or spot fleet, and you just want one spot instance or a single spot instance or something like that, you can go to launch instances. Okay, like when you are creating a single EC2 instance, and if you go back over here, okay, in the advanced details, sorry, what happened, let's go to advanced details, and you can go for request spot instances. Okay, then what it will do, when you request for spot instances, there are certain things, okay, that you need to do. Then you can select whatever you want, like your configurations and everything, and you are good to go. And you can also customize it, so you can set your maximum price that you want, like basically, okay, if the maximum price, if the spot price goes below this maximum price, for example $2, the spot instance will be provided to me, something like that. Okay, so yeah, that's how you can do different kind of EC2 instances. For example, if you want to launch a reserved instance, right, or a dedicated host, for example, you can go over here and allocate dedicated host, and you can just give the name tag, instance family, what kind of thing you want, like the instance type, and a lot of other similar kind of resources you want, and then you can allocate. So it will actually give you a lot of money. So a lot of money will be spent, so I'm not going to do that. So let us go back to EC2, and you can also create a savings plans. Okay, so it is flexible, so purchase savings plans. So saving plans is a flexible pricing model that offers low prices on EC2. So you commit to a 1 or 3 year term plan, and you say that, okay, I'm going to use it 2 hours every day for 3 years. Okay, and anything beyond that, as we have discussed, is going to be coming under on demand. Okay, so that's what savings plan is. So yeah, so that was some types of instances that you can request, and yeah, so that was about it. So yeah, before going wrapping up your things, okay, remember to terminate all EC2 instances and everything, so just so that you are not charged a lot. So let's go to instance state and terminate instance. Okay, terminate the instance, we don't want that. Okay, and also I'm going to go into my this thing, and I'm going to go to roles, and I'm going to remove certain roles from here. Okay, just going to delete those roles. So these cleanup things you should always do after you are done with your AWS practice or something, so that you don't get charged for a lot of stuff. Okay, so yeah, so that's about it. If we go back, and we're going to see the summary of the basics of EC2. So EC2 instance consists of AMI, instance size, storage, and security groups, plus EC2 user data. We have security groups, firewall attached to an EC2 instance. We have user data. We have SSH to start a terminal into our EC2 instances. EC2 instance role, link to IAM roles, we have already seen, and we have a lot of purchasing options like standard, convertible, scheduled, reserved, dedicated host, and dedicated instance. Okay, so let's move on to the next section. So guys, we just saw one of the phenomenons, right? What happens is that when we try to stop our instance, right? So it has successfully stopped. So let me just refresh this thing. So it is in stopping state. So when we stop our instance and then we start our instance, so what happens is that our public IP gets lost. It means that basically AWS just selects another IPs from its pool of IPs and just assigns it to your particular EC2 instance, right? So if I just stopped, so let me just select this and let me start my instance. So it is in pending start. Okay, just a minute, let it start. So so I can see that the public IP address has changed. Now this is basically you cannot actually prevent it in a normal way. So let's see how we can prevent it, and let's see how we can if we can access, give a particular fixed IP address to this particular EC2 instance. So let us have a deeper dive into this EC2 series. The first thing that we need to discuss is private versus public IPs. Okay, so it's a very simple thing. Basically, if your web server is public, okay, then you can access it over the internet and it is associated with the public IPv4 address. But if you have your own private network, for example your home network, you have a routing enabled and everything, and it's your own private network or your company network, right? Then you can assign private private IP addresses to your devices, but they only can communicate within that network, right? They cannot communicate publicly. Okay, so basically if there is a device which needs to be communicated publicly, you need to assign a public IPv4 address, right? Now basically that's what we said, right? So private IP means the machine can be identified on a private network only. But two different private networks, two companies can have the same IPs, because see, if a particular company has IPs in a particular CIDR range, IPv4 CIDR range, then another company has their own network and they can have the same CIDR range allocated to their own private network. It is possible because both cannot communicate with each other and both are not publicly available. So that is possible in case of a private IP, but in case of a public IP, no two devices cannot have the same public IP, right? Because it is not possible, otherwise there will not be a unique identifier for your devices. So elastic IPs is the solution for that particular EC2 instance if you want to assign a fixed IP to an EC2 instance. Okay, so an elastic IP is a public IPv4 IP you own as long as you don't delete it. You can attach it to one instance at a time. Okay, with an elastic IP you can mask the failure of an instance or a software. So basically you can only have 5 elastic IPs in your account. Okay, overall, but the thing is, try to avoid elastic IPs, even though it's a solution, but you shouldn't use elastic IPs that much because they reflect poor architectural decisions. Instead, use a random public IP and register a DNS name to it. It is much better. Now you already have a fixed DNS name. The IP may change, but it will automatically point to your IP, that DNS name. Another good way to do that is to make a load balancer, and basically you assign a DNS name to your load balancer and use your load balancer to communicate privately with your EC2 instances. In this case, you save a lot of money as well as you are doing a very good architectural decision. Okay, let's see some hands-on regarding elastic IPs. It's very easy to do one. So basically let me just stop the instance. So let me just select it and let's stop the instance. Okay, now what I'm going to do is over here, if you see, there is something known as elastic IPs. Okay, now here we just have to do is allocate elastic IPs, and you have to select a network border group, select an IP in Amazon's pool of IPv4 addresses, and I think that's it. You just click on allocate. So remember that basically this IP, you will be charged for this particular IPv4 address, so quickly after the demo just delete it. Okay, so what you can do is I can go to my instances, go back to my instances. Okay, so here are our instances. Okay, our only one instance is there. So we have created our elastic IP. Now we need to attach this elastic IP to our instance, right? So I'm going to go back to my particular elastic IPs that I just had created, okay, and I'm just going to click on this IP, and I'm just going to say associate elastic IPs, and I'm just going to select the instance as this particular instance that has been created there, and then associate that particular IP with the particular EC2 instance. Okay, now if I go back to my EC2 and go to my instances, and let me just start my instance. So note that particular elastic IP, okay, so it is 107.23.221.80. so let me go back to my EC2 instances and let me just restart this particular instance. I'm just going to start this instance, okay, so it will take like 1 minute or something. Let's wait for a minute. Okay, so you can see that public IPv4 address now has been attached for that particular EC2 instance from that particular elastic IP. Okay, so now if I just try to stop and restart my instance, the same IP will be reassigned. Okay, now let me go back to my elastic IPs and quickly delete that IP so that I'll not get charged a lot. Okay, so I'm just going to say I'm going to go to the elastic IP. Okay, I'm just going to go to actions and just say release elastic IP addresses. Okay, so I cannot release the associated IDs because it has been associated with a particular EC2 instance. So what I'm going to do is I'm going to go to my instances, okay, and I'm just going to go to my instance state, and then I'm just going to stop my instance, stop this particular instance. Okay, so let me just refresh it. Okay, now let me just go back, so it will be stopped. Let me just go back to my elastic IPs, and this is my IP. Now in actions, let me just release elastic IPs. Okay, it is still associated because that particular thing, EC2 instance has not stopped. Okay, so let me disassociate them first disassociate them. Okay, now that instance is stopped and my elastic IP has been disassociated, let us release the elastic IPs. Okay, now it is done, so I have no elastic IPs right now. Now let me go back to my instances, and if I just restart my instance, and if you see the next time it restarts, you will get a particular IP which is different from that elastic IP, because now randomly one IP will get allocated. Okay, so I'll just going to refresh. Okay, it is still pending. Okay, now if you see that as we have released our elastic IP addresses, now the public IPv4 address has changed. Okay, now let's talk about some other stuff right now. Okay, now let's talk about placement groups. Okay, and it is very important to understand what placement groups are. Sometimes you want to control over the EC2 placement strategy, like how do you want to place your EC2 group, EC2 instances, right? That strategy can be defined using placement groups. So strategies for the group: one is the cluster placement group, one is the spread placement group, and one is the partition placement group. So let's see one by one how this particular placement groups work and what are the advantages of using each of those placement groups. Now talking about the cluster placement group, it is a great network. It can give about 10 Gbps of bandwidth between instances when enhanced networking enabled. Okay, cons: if the rack fails, all instances fails at the same time. So basically all your EC2 instances are present in the same rack, so it will provide you high performance and great network throughput. So it is basically if you have some big data job that needs to complete really fast, and application that needs extremely low latency and high network throughput, you can go for this particular placement group. Talking about the spread placement group, now as you can see in this diagram, the particular EC2 instances are spread across multiple availability zones, right? So the thing is, you will go for spread placement groups if your requirements are high availability. Okay, basically if one of your particular instances fails in one availability zone, other instance can just take up the role and can be available at the same time, right? So it is kind of a disaster management recovery actions. Okay, so that is why where you can use spread placement groups. Now talking about partition placement groups. Now basically partition placement groups, basically what you do, you can have up to 7 partitions per AZ. Okay, so basically can span across multiple AZs in the same region. Okay, now if you're going to compare partition placement groups and where you're going to use it, just think about Hadoop. Okay, so basically where you need distributed storage, right, like HDFS, HBase, Cassandra or Kafka or Hadoop, any kind of those kind of requirements, you should use partition placement group, because basically your instances are separated into partitions. They can be in the same availability zone or they can spread across different availability zones, but remember you can have up to 7 partitions per AZ only. Now let us talk about partitions and how you can create a partition in particular AWS. It is very easy to create partitions. So if you see over here, let me just go back over here, and there should be a placement groups over here. Okay, here we have placement groups, and basically it is very easy. Just select on create placement group, name it as my cluster placement group. Okay, and just you need to choose the strategy. So I'll just select cluster, and then I'm just going to create the group. That's it. That's the easiest thing I think possible. Now if you want to create an EC2 instance, just go to instances, launch instance. Okay, and just if you just go all the way down to advanced settings, right, advanced details or advanced settings over here, and where is it? Okay, if you just go down to advanced details, and if we just go over here to I think placement group, then just select the placement group as my cluster placement group, and then what will happen, whatever EC2 instances you will going to create, and you will select this particular my cluster placement group, the particular EC2 instances will be created as per your placement group. So I'm not going to create an instance right now. I'm just going to hit cancel, and I'm just going to go back and delete my placement group, and then I think you are good to go. That's all about placement groups. Just I'm going to hit delete, and that's it. My placement group has been deleted. Okay, so let's talk about one other important feature, which is known as Elastic Network Interface, or it stands for ENI. Okay, now a logical component of VPC that represents a virtual network card. So if you can know, every system has virtual network cards which provides you a set of IP addresses, right? If you do not have a network card, then basically you will not have IP addresses and your device will not be able to communicate with one another. So basically an ENI can have the following attributes. One is primary private IPv4, one or more secondary IPv4, okay, and one elastic IP per private IPv4, one public IPv4, one or more security groups, a MAC address. So these are all, and the ENI can have this following attributes, right? You can create ENI independently and attach them on the fly, move them on the instances for failover. So it is bound to a specific availability zone. So if you see this diagram over here, so there was an ETH0 which was a network card associated, which was the primary ENI, and it had a particular IP address associated to it, and then we attached another network interface, which is ETH1, and it has a secondary ENI, and it has 192.168.0.42. This is another IP or a private IP. Okay, so what you can do, you can just detach this particular ENI from this EC2 instance and can attach it in this EC2 instance in a matter of seconds. Okay, now it is very cool feature. Okay, now let's see how you can do that. So I'm just going to go to my console, and what I'm going to do is I'm just going to go to network over here, and I'm just going to go to network interfaces. Now if you see here, we have only one elastic network interface, and that has been attached to our particular EC2 instance that we have created, right? So that is obviously because when an EC2 instance is created, it is associated with a public IP and a private IP, so automatically one ENI has been created for your EC2 instance. Now what I'm going to do is I'm just going to say create network interface, and I'm just going to say uh, just let me do one thing. So I'm going to open EC2 in a new tab, so that if I want to switch back to my instances, it will help me a lot. Okay, so I'm just going to say open link in a new tab, and I'm just going to go over here and just go to my instances and keep that particular tab on for the meanwhile. Okay, and if you just have a look at this particular EC2 instance, and if you go to networking over here, right, if you go to networking over here, sorry, okay, it's not going to go there. So basically if you just go down, we have one network interface attached to it, so it is ENI 02B, and basically if we just go to our network interfaces over here, it is the same network ENI which has been attached to our instance. Now let us create a new network interface. I'm just going to name the description as secondary ENI. Okay, and you need to select a subnet, right? Basically you need to create a subnet. Basically you don't have to create a subnet, sorry, for now. So what I need to do is, so I'm going to select a subnet which is in the same availability zone as the particular my particular EC2 instances, because as I have told you, an ENI is bound to a particular availability zone. So US East 1B. So I'm just going to go over here and US East 1B. So basically that is the subnet that has been associated with it. So I'm just going to select that. I think I just got it right. Okay, great. Now private IPv4 address, I'm just going to say auto assign. Elastic Fabric adapter is just another feature which promotes high performance computing, but we don't need that, so just leave it like that. So launch wizard 2, I think this is the security group attached to my particular EC2 instance, right? So let me just, if you see somewhere if I go over here, okay, so it is launch wizard 1. Okay, so basically I'm just going to say, okay, launch wizard 1, that is my security group, and then create the interface, network interface. Now if you see, my network interface has been created. I have two of them. One is this 02B which was already assigned, and then there is ENI 053 which I just created right now. Okay, now let us go to instances, and what I can do is, if I go to my okay, over here, and okay, let me go to my network interface, new network interface that I've created, ENI, and I'm just going to go to actions and attach that particular ENI with my EC2 instance. I'm going to select this particular EC2 instance that is present over there, and I can attach that particular ENI to my EC2 instance. Now if I go back to my instances over here, and if I go to networking over here and scroll down, let me just refresh it, and let me select it back, and let me go to networking. So if you see, now it has been attached with two ENIs. One is this primary, one is the secondary ENI which I had just created, and it has a private IPv4 address, but it doesn't have a public IPv4 address, right? Because because we have only assigned a private IPv4 address, and basically this is how you can do it. Now so if you have, so basically for example, your this instance failed for some reason, or it crashed, right? So basically what you can do, you can just take this ENI, you can just detach this ENI from this particular EC2 instance, and I can reattach that particular ENI to another EC2 instance. So basically just go over here, and you can just say actions and just say detach, and just say basically detach that particular ENI. And then what you can do, if you have another EC2 instance, you can just attach this particular ENI to that particular EC2 instance. Okay, so this is how you can do and work with network interfaces or ENIs. Okay, so that sounds good, right? Now let us go back to another topic which is known as hibernation in EC2. So basically in hibernation, what happens is, we know we can stop terminate instances, right? We can stop the terminate or stop the instances, or we can terminate the instances. Stopping the instance, the data on the disk is kept intact in the next start, but if you terminate, the root volumes which has the delete on termination feature will be destroyed, right? So on start, what is happening, the following thing happens. So on the first start, the OS boots and the EC2 user data script is run, right? basically whatever you place, the script that you place in the EC2 user data part, it is run, and the following starts, the OS boots up, because after the subsequent times the user data script doesn't run again. Then your application starts, caches get swarmed, and that can take time, right? Because on every start your application is not running. As your OS boots up, then you have some kind of script, and that particular script starts up your application, so that your application needs some time to actually start up. Sorry, and it can take some time. So hibernation, now introducing hibernation in EC2. So the in-memory RAM is preserved, this RAM state is actually preserved. So what is happening, you are running an application, right? And what you do is you kind of freeze that particular application state in your RAM. Okay, now basically you hibernate your EC2 instance. The OS is not stopped or restarted, remember is that. So under the hood, what is happening, the RAM state is written to a file in the root EBS volume. The root EBS volume must be encrypted. Okay, if it is not encrypted, then that is not possible. Then what is happening, when you just return your EC2 instance back from hibernation, the particular data that was written, it just goes back from the particular EBS volume to your RAM, and then you have a fully application running on the start, you can just say. So here if you see in this diagram, running, hibernate, stopping, okay, shut down, basically stopped, and then you restart it, then basically just take the particular data from the RAM itself. So that state is maintained. You can just understand it like your application is kind of in a freezed state, and then when you just hibernate your disable hibernation from your particular thing, when your application, your EC2 instance goes back to the running state, basically you save a lot of time. Now hibernation in EC2, some good things to know. Supported instance families C3, C4, C5, I3, M3, M4, R3, R4, T2 and T3. Instance RAM size must be less than 150 GB. Okay, instance size not supported for bare metal instances. It means that if there is a instance on your particular on-premises network, then it doesn't support it. Only supports EC2 instances. Okay. AMI is Amazon Linux to Linux AMI, Ubuntu, RHEL, CentOS and Windows. Root volume must be EBS encrypted. Okay, available for on-demand, reserved and spot instances. An instance cannot be hibernated more than 60 days. Okay. Okay, so yeah, that was about it. Let me just go to actions and terminate my instance. I don't need this instance anymore. I'm just going to terminate this instance. And if I go to launch instances, right, and basically if I go over here, if I go to advanced details, so this is stop hibernate behavior, just enable hibernate behavior, right? So basically what will happen, this will enable hibernate behavior, and basically you can apply hibernate to your EC2 instance. Okay, that's how you enable hibernate. So that was a simple demonstration of how you can do it. So if I just do it, then my particular EC2 instance must get it is getting terminated. I'm also going to do some cleanup right now. I'm going to go to my network interfaces, and there is a ENI over here which I had created. So I'm just going to select that ENI, and I'm just going to go to actions and delete that ENI because I don't need it. So always try to clean up whatever you what you have done, okay, because it is always important that you don't use a lot of that you do not use up a lot of your resources, and also you need to keep your particular AWS console clutter free. Okay guys, yeah, so that's it for the video, and I think I'll see you in the next video. Thank you.